All right, guys, I'm going to do this recording about parent functions. All right, make sure we're just getting the screen record. Excellent. Hopefully it stays the whole time. I have a little trouble getting these recordings to continue as I do them. All right, here we go. So the first function that we're going to need, I need you guys to know, is the linear function. All right, this is the most basic form. And so if you plug in any of these numbers, you're going to get exactly the same value in the y value. So when you guys did this a ton in Algebra 1, the idea is you have a slope of 1 and you're moving through the y-intercept at the origin. All right, so this is the most basic function for a linear function. The domain is all real numbers, or negative infinity to infinity. Same with the range. We're going to get every single y value. It has something called origin symmetry. It's symmetrical about the origin. The idea being, if I were to graph this point 3, 3, if I move across the origin, there is a point, the mirror image of that, at -3, -3. When you have origin symmetry, a function is called an odd function. What might help is to think that this is raised to the first power, when you should know that the number 1 is odd. So that's why this is an odd function. The x-intercept and the y-intercept are both the origin. That's the linear function. Let's move to my favorite function, the quadratic function. All right, this is going to be a parabola. All right, I left a few of these numbers here. Sorry about that. When you square these numbers, they become positive. So -2 squared is +4. -1 squared is +1. And you saw my numbers here. 0, 1, and 2 squared is 0, 1, and 4. Graphing these points, you'll notice we are creating a parabola. This U shape. All right. You should have done a little bit of this in Algebra 1. We'll do a lot more in Algebra 2. In terms of the domain, we can plug in any value for x. That's no problem. You can square any number. So negative infinity to infinity. But we are not going to get every single value for the range because we don't have any values that are negative. When you square something, they always become positive values. So my range is going to be 0 to infinity, and we are going to include 0, hence the bracket. In terms of symmetry, we have what is called y-axis symmetry. You can think of this as, right, if I look at this point 2, 4, there's a point over here across the y-axis, right, across this axis, that is symmetrical. All right, so when you have y-axis symmetry, you have a function that is called an even function. All right, that shouldn't surprise you, hopefully. If you were to look at the number here, that number 2 is an even number. The x-intercept and the y-intercept are both the origin. Let's do the parent cubic function, x to the 3rd power. All right, I'm going to cube these numbers, and this time you're going to see I do have negatives. -2 cubed is -8. -1 cubed is -1, and 0, 1, and 8. So plotting these values, I think this description is very appropriate, saying that you're going to look at a graph that curves like a river up the y-axis, right? So it kind of looks like this. I used to think of it kind of looks a little bit like an S shape, or whatever helps you remember how this looks. All right. Now, in terms of the domain, you can plug in any number you want into this function. You're going to get every single number is fine. We're moving all directions here. In terms of symmetry, this has origin symmetry like that linear function. So it is odd, and the x-intercept and the y-intercept are both 0, 0. That is the cubic function. Let's do the absolute value function. Now, this absolute value function graph is a V shape. You're actually going to see it's really 2 linear pieces connected at a point that's called a vertex. And if you remember from your days in middle school, you should hopefully remember the absolute value symbol measures the distance of a number to 0. So because it's about distance, it doesn't matter if you're moving from the left or from the right. So that's why students will always say the absolute value means always positive. So these y values are going to be positive numbers, except for that 0. So plotting this, you'll see that I have a linear function with a slope of +1 moving to the right, and then a linear function with a slope of -1 over here, which creates that V shape. All right, so the domain, you can plug in any number you want. But be cautious on the range of this because we don't have any values below the x-axis. We don't have any negative y values. Our lowest y value is 0 all the way up to infinity. We are including 0, which is why I put that bracket. In terms of the symmetry, it has y-axis symmetry, and this is another even function. The x-intercept is the origin, as well as the y-intercept. All right, let's do the square root function. Now this square root function, the square root operation is the inverse operation of squaring something. So this description of that the graph is like half of a sideways parabola, right? Ultimately, it would include the whole thing, and I would show you that in class. But if we include the whole parabola on its side, you'll see in class it's going to violate the vertical line test, so it would not be a function. And you'll also notice this is the first time that these input values are not -2, -1, 0, 1, and 2, right? We cannot plug in negative numbers to take the square root of them, and we have to be strategic of numbers that we know, right? I don't know the square root of 2 off the top of my head, so I'm not going to use that. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. Well, I'm not going to be able to do that last one, but I think you'll get the idea of where we're looking here. That's too high, sorry about that. All right, and so this is that half of a parabola on its side. Okay, in terms of the domain, we can't plug in any negative numbers, so it's going to be 0 to infinity, as well as the range. We're only going to start at 0 and move all the way up to infinity. It does not have any symmetry in terms of this square root function, so I don't need to write anything there, right? So that's not applicable. The x-intercept and the y-intercept is still the origin. All right, our last one, the cube root function. You'll notice that we, kind of like the one previously, are not using the numbers we have been using of -2 through +2. We're using -8 because I hope that you know that the cube root of 8 is 2, so the cube root of -8 is -2. This one is -1, 0, 1, and 2. Again, so be strategic on these values that you choose. So -8, -2, -1, -1. We'll keep going. You're going to see it looks just like the cubic function, but instead of moving up the y-axis, this is moving across the x-axis. All right, so there is the cubic function. The domain and the range is the same as the cubic function. It is all real numbers. In terms of symmetry, it has origin symmetry, right? Things are going to be a mirror across the origin. So this is an odd function, and the x-intercept and the y-intercept are still the origin. All right, so these are the 6 parent functions that I need you to make sure you commit to memory and know how to sketch them if I ask you to sketch them.